man mahusgahan nila.
Okay, we have a problem. This problem is a non-uniform circular motion. So a small sphere of mass m is attached to the end of a cord of length r and set into motion in a vertical circle about a fixed point O, as illustrated in the figure. Determine the tangential acceleration of the sphere and the tension in the cord at any instant when the speed of the sphere is b and the cord makes an angle theta with the vertical. So we have here the illustration. For example, this is the center of this circle. There is a sphere initially at the bottom that is attached to a cord of radius r. We have the free body diagram, and the free body diagram will show that there will be a tension at the bottom, and it will be acting upon by a weight that is vertically downward, which is equal to mg. That's the weight. Velocity at the bottom. It is going in a counterclockwise direction in this case. Now, we illustrated at the top, of course, there will be the tension in the cord at the top that is going downward and the weight that is going downward also. So, the velocity will always be tangent to this imaginary circle. We also draw an illustration at any instant. So at any instant we have the tension in the cord T that is going toward the center, and of course there will be a weight mg that is directed downward. Now this mg, if we are going to resolve it into its component, we have mg cosine theta, which goes radially. Okay, this is along the radial direction, and mg sine theta that is tangent to this circle. So we are asked to find the tangential acceleration and the tension in the cord. These are the required. So we say solution. If we're going to apply Newton's second law of motion along the tangential, okay, the tangential direction, this is it. Okay. The only thing we see is mg sine theta, and that will be equal to mat. So summation of forces at the tangential direction is equal to mat. Of course, that will be the direction. Okay. Now we are having here upward to be positive. Okay, and to the right to be positive. So mg sine theta will be positive. Mg sine theta is positive, and that will be equal to ma, and that a is tangential. But what is the sign of this one? This is going upward, therefore upward is positive. Therefore, if we will evaluate this, m and m will cancel out. Therefore, we have the tangential acceleration is equal to g sine of theta. Now, if we are going to sum up forces, summation of forces along the radial, okay, is equal to ma, but this ma is along radial, that will be centripetal acceleration. So what is the forces along radial. We have upward to be positive lagi, ano? Upward to be positive. T is directed upward. T and then minus mg cosine of theta. T minus mg is equal to mb squared over r. And what's the sign of this? We are going upward like that. So therefore that is equal to positive. What happens is we have T is equal to mb squared over r. Transpose this to the other side of the equation, that becomes positive, plus mg cosine of theta. Therefore, T, okay, let us factor out mg, no? Dividing both sides by g first, and then we take out the common factor m. Therefore, we will have here mg. Hindi ko na pinakita. That's how you factor this one out. You divide both sides of the equation by g, and then you will take out the common factor m in the right side, and then afterwards you multiply both sides by g. So we will have mg, and this one is b squared yung natira doon over gr. Okay, gr or rg. So mg to, di plus cosine theta na lang. So may cosine theta na lang tayo dito. So there you have it. We have solved for the tension in the cord. So this will be the tension in the cord, and this will be the tangential acceleration. So meron tong follow-up question. Let us pause for a while. Okay, we are asked to evaluate the result at the top and the bottom of the circular path. Now, may pagkakaiba ito doon sa Ferris wheel, ano? Yung sa Ferris wheel, yung normal force natin, kung mapapansin mo. So, let us say that we have this cart, and there is the child that is sitting in this Ferris wheel. Yung normal force natin is always acting upward, and the weight is always acting downward. Where in this case, the ball, the tension, is always acting toward the center. So ito naman sa kabila, the normal force and the weight mg is always acting downward. Dito naman, meron tayong bola, the tension is always acting towards the center. And the weight, of course, naturally, it will be always acting downward, mg. Kung nandito tayo sa baba, the tension will be upward and the weight will be downward. Okay. So, yan yung pagkakaiba natin. Nevertheless, hindi naman tayo malilito dyan dahil sanay naman tayo sa Newton's second law of motion. You just have to consider that the upward or the upward direction to be positive. Okay. Ang key takeaways na lang natin dito, paikot siya, no? Pa-counterclockwise yung ikot. So kapag ka nasa taas na siyang ganyan, ang tendency ng acceleration will be going downward, and pag nandito naman, the acceleration will be going upward. So sabihin natin itong tension at the top, at ito ay tension at the bottom, ano? Okay, tension at the top and tension at the bottom. Yung tension at the top, yung acceleration niya pababa. Okay, pababa yan, yung acceleration. Dito rin naman, yung acceleration naman niya rito is pataas. So let us apply Newton's law of motion in this case. So we say, for example, dito muna tayo mag-concentrate sa tension at the top. Dito muna, no? Summation of forces at y is equal to MA. Okay, that will be centripetal. So therefore, we will have the forces. What are the forces? Negative T top, negative T top, and then minus, because upward is positive, ano? Upward to be positive. That is our convention. So minus mg pa rin yan. Minus mg is equal to MAC or MB squared over R, because this AC here is centripetal acceleration, no? MB squared over R. But what is the direction? This is going downward. This will be negative. Therefore, everything is negative. We can make it all positive. Therefore, we have to multiply both sides of the equation by negative. We have T top that is now positive is equal to, we transpose this to the other side of the equation. So this is positive na, no? Positive. We will transpose that, it will become negative. And this is negative, it will become positive because we are multiplying everything by negative 1. This will be mb squared all over r. And this positive mg will become negative mg. Okay. So what we're going to do is to factor out mg. Okay, so t top, ganun pa rin, divide all terms by g, or both sides of the equation by g, and then you factor out m, and then multiply both sides by g. So we have mg, lalabas na yung mg rito ngayon, and then that will be multiplied by b squared over rg, or gr minus 1. So that will be our tension at the top. So how about this one? Tension at the bottom. Let us magnify this one. So buray na natin to, no? And mag-concentrate tayo dito. So tension at the bottom, kung ito yung bottom natin, meron tayong pababa, which is mg, meron tayong pataas. So we are looking at this one, ano? Summation of forces at y is equal to MAC, 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 upward to be positive. Okay, upward positive. So what are the forces going upward? That will be T at the bottom, the tension at the bottom minus mg. So in this case, acceleration is going upward, therefore MAC is equal to positive. MAC, but what is AC? B squared over R. B squared over R. So the t at the bottom, we transpose that to the other side. T at the bottom will be equal to mb squared over r plus mg. So we factor out mg. T at the bottom becomes mg. Then we will have b squared over gr or rg, whatever. So this is plus 1, no? Plus 1. Because this is negative, we transpose that to the other side. Therefore, you have here the t at the bottom. Okay, that's how simple it is. Tandaan nyo lang lagi kapag ka nagkakaroon tayo ng application ng Newton's second law, you have to consider where it is going. If the velocity is going upward, therefore MA is positive. And if the velocity is going downward, MA is negative. Okay. So I guess meron pa rin itong follow-up question. We will pause for a while and then we will type. So we have a follow-up question here. What is the speed would the ball have as it passes over the top of the circle? So dito daw sa top of the circle. If the tension in the cord goes to zero instantaneously at that point. Instantaneously at this point, the tension is equal to zero. Sa tension of the top natin kanina, we have solved for this one. This one is actually mg. And then we will have the quantity b squared over gr minus 1. So if this one is 0, so that is 0, that becomes 0 divided by mg is equal to b squared over gr minus 1. So this is still 0. So that is 0. We transpose this one to the other side of the equation. So we will have positive 1 is equal to b squared over gr. And we cross multiply, we have gr is equal to b squared. We extract the square root of both sides, we have b is equal to the square root of gr. So this is your answer. B is equal to the square root of gr. That will be the instantaneous speed at the top. So this one is the velocity at the top. Now if we are asked what speed would the ball have? It is if it passes to the bottom naman. So sa bottom we have here ang bottom natin t at the bottom is equal to mg, ano? Mg times b squared over gr and then plus 1 tayo doon kanina. So this is 0 and this one will be 0 na rin kasi pag dinivide mo yan will be 0. This becomes negative 1. So multiplied by gr, that will be multiplied by gr. And we have there b squared, stuck the square root. So we have extracted the square root of both sides. B is equal to square root of negative GR. Okay, so this one is in the bottom. Now, you will say, bakit naging negative to? So this will be undefined, ano? So if that will be undefined, paano natin na maipapaliwanag yan? Okay. So remember, we are at the bottom. Kung nawala man yung centripetal force natin dito, yang bolang yan laging babaksak dito. It will never happen na yung tension at the bottom is zero. So the tension at the bottom can never be zero. Bakit? Otherwise, naputol yung sinulid mo yan or yung cord na yan. Kasi kung wala mang centripetal force na gagana dyan, this sphere will always stay at the dead bottom, aligned with this one, 90 degrees. Therefore, tension at the bottom can never be zero because mag-i-infinity nga yung ating or mag-undefine nga yung ating equation. So, meron tayong consistency, ano? Hindi rin pumapayag yung equation natin na magiging zero yung tension at the bottom at hindi rin talaga mangyayari sa actual analysis na magsisiro yun dahil kapag nagsiro yun ay putol yung ating kable. Sa taas pwedeng magsiro. So kung nagsiro yan, the velocity is square root of GR. So yun lang yung key takeaways natin dyan. Ano? Sorry for the handwriting. So this is tension at the bottom will never be zero. I guess by now we have solved sufficient amount of problems for you to be ready to face circular problems, be it uniform circular and be it non-uniform, be it horizontal or be it vertical. Now I prepare to discuss this topic alongside with the rotational motion para hindi ko isiningit itong circular motion when we are in the rectilinear motion para yung concentration ng isip natin dire-diretso, no? So expect on my next video, we will be touching on the other topic which is rotational motion. That is chapter 10. Tama-tama yun, kakatapos lang natin na circular, we will having rotational motion. We will be talking about angular velocities, angular acceleration, and angular displacement. So with this, I guess I have to end our circular motion topics. So with this, we will end up our circular motion topic. So thank you and God bless us all.